Let us look at rectification of a curve when the curve is given in a polar form and in the parametric form. So first let's look at polar form. So r is equal to f of theta is the curve given. Then ds by d theta is equal to square root of r square plus dr by d theta square. This we know from differential calculus. Now to figure out the arc length, we integrate this. So we get s is equal to integral of square root of r square plus dr by d theta square d theta from alpha to beta. This polar form could be r equal to f theta, or it could be theta is equal to f of r. In which case ds by dr is equal to square root of 1 plus r square times d theta by dr square. And in this case, s is equal to the integral from r1 to r2 of square root of 1 plus r square times d theta by dr square dr. So here the radius vector is equal to f theta. That is, radius vector is a function of theta. Here theta is a function of r. Now let's look at an example. Let's say we are given the curve r is equal to a times 1 plus cos theta. And if we plot this, we get this. This is called a cardioid. Now looking at this graph and otherwise as well using differential calculus, we can figure out the shape of this curve. We know that symmetric across x-axis. Now we have to figure out for what values of theta is r equal to 0. So a times 1 plus cos theta is equal to 0. Solving this, we get 1 plus cos theta equal to 0, cos theta equal to minus 1, which means theta is equal to pi. And when theta is equal to 0, r is equal to 2a. So here, this is 2a. This distance is 2a from B to A. And here the angle is 0 because the radius vector BA is on the x-axis. Now, as we rotate it and we reach the point B, the angle formed is 180 degree, that is pi. So we have theta is equal to pi and theta is equal to 0. Now, since it is symmetric across the x-axis, what we can do is focus on one side, figure out the arc length and multiply it by 2 to get the length of the curve, entire curve. dr by d theta we require. So if we differentiate r is equal to a times 1 plus cos theta, we get dr by d theta. Here we are differentiating with respect to theta is equal to a times 1 is a constant, so 0. A cos theta, differentiating it, we get minus sine theta. So we have minus a sine theta. ds by d theta is equal to the square root of r square. Now r square is a times 1 plus cos theta square. So we have a square times 1 plus cos theta square plus dr by d theta square. dr by d theta is minus a sine theta. So square of that. Simplifying it, a square times we get 1 plus 2 cos theta plus cos square theta. Opening up this bracket, the square will make this minus disappear. So we have plus a square times sine square theta. Now a square cos square theta we have. A square sine square theta we have. So a square is common. We take it out of the brackets. And within brackets, we will have 1 plus 2 cos theta plus 1 because cos square theta plus sine square theta is 1. Now a square, we take it out of the square root. A times square root of 2 plus 2 cos theta. That is 2 times 1 plus cos theta, which is equal to a times square root of 2 times 1 plus cos theta is 2 cos square theta by 2. That's the identity, trigonometric identity. Now 2 times 2 is 4, so we can take it out of the square root as 2 cos square theta. So square and square root will cancel. So we have 2a times cos theta by 2. So now we have ds by d theta we have got. What is the next step? S is equal to ds by d theta integral from a particular angle to another angle. So we have S is equal to 2 times the integral from theta 1 by 2 theta 2 of square root of r square plus dr by d theta square d theta. Substituting the values, we get S is equal to 2 times the integral 0 to pi ds by d theta, which is equal to 2 times the integral from 0 to pi of 2a times cos theta by 2 d theta. So here we are looking at 0 to pi. Why 0 to pi? Because that is where the curve intersects the x-axis, across which it is symmetric. S is equal to 2 is a constant, we take it out, so 4a, a is also a constant, times the integral 0 to pi of cos theta by 2 d theta. Carrying out the integration, we get S is equal to 4a times cos theta by 2 integral is sin theta by 2 times 2. That 2 comes out and we get 8a times sin theta by 2 from 0 to pi. Taking care of the limits, we get S is equal to 8a times sin pi by 2 minus sin 0. And finally, we get S is equal to 8a times sin pi by 2 is 1, sin 0 is 0. So 1 minus 0 is 1. So 8a times 1, which is 8a. So depending on the value of a, multiplying it by 8, we get the, we can say, perimeter or the arc length of the curve. So that was one example using polar form. Now let's look at the parametric form. Here x is equal to f of t and y is equal to g of t. So the parameter is t. ds by dt is equal to square root of dx by dt square plus dy by dt square. And as usual, to get s, we integrate in a given interval. So integral from t1 to t2 of square root of dx by dt square plus dy by dt square dt. Now let's look at an example. X is equal to a times theta minus sin theta. Y is equal to a times 1 minus cos theta. This is the parametric form of a cycloid. And we want the arc length between 0 and 2 pi. So let's see how this looks like. It looks like this. So here again, as you can see, it goes like this. But we are interested only in the interval 0 to 2 pi. So let's proceed. First, we figure out for what values of theta would y be equal to 0. So a times, since we are talking of y equal to 0, we take the second equation. Y is equal to a times 1 minus cos theta is equal to 0. That means 1 minus cos theta equal to 0, minus cos theta is equal to minus 1. That means cos theta equal to 1, which means theta equal to 0 or any integer multiple of, positive integer multiple of 2 pi. We can also make it as an integer. But here we are interested in 0 to 2 pi. Okay, so that means we know the limits 0 to 2 pi. We need dx by dt. Here, of course, our parameter is theta. So we need dx by d theta. So dx by d theta is equal to x is this. So we differentiate it with respect to theta. A theta, if we differentiate, we get a1 minus a sine theta. If we differentiate, we get minus a cos theta. And 1 minus cos theta is equal to 2 sine square theta by 2. So dx by d theta is equal to a times 2 sine square theta by 2. Again, we require dy by d theta. So differentiating y is equal to a times 1 minus cos theta. 1 is a constant, a is a constant. So the product of that, when we differentiate, we get 0. We are left with minus a cos theta. So when we differentiate that, we get a sine theta. And sine theta can be written as 2 sine theta by 2 times cos theta by 2. Again, a trigonometric identity. So now ds by d theta is equal to this expression, square root of dx by d theta square plus dy by d theta square. Putting the values in, we get ds by d theta is equal to square root of dx by d theta, that is 2a sine square theta by 2 the whole square, plus dy by d theta, that is a times 2 times sine theta by 2 times cos theta by 2 square. Let's simplify this. We get square root of 4a square sine to the power of 4 theta by 2 plus 4 times a square times sine square theta by 2 times cos square theta by 2. Now 4a square is common to both the terms. We take it out of the square root. So it becomes 2a times square root of, now sine square theta by 2 and sine square theta by 2 is common. So we take it out. So sine square theta by 2 times sine square theta by 2 plus cos square theta by 2 we have. This sine square theta by 2 plus cos square theta by 2 is 1. So we are left with 2a times square root of sine square theta by 2, which means ds by d theta is equal to 2a times sine theta by 2. So square root and square cancel out, and we need to add the absolute signs here. Now, what is the next step? Next step is to integrate. So s is equal to 2a times integral from 0 to 2 pi of sine theta by d theta. Now, the reason the absolute value disappears here is because in the interval 0 to 2 pi, sine is positive. So we don't have to bother with the absolute value. That is what is mentioned here. Sine theta by 2 does not change sign in this interval, so we can drop the absolute sign. Now, very quickly, let's integrate this. Let u equal to theta by 2, which implies du is equal to d theta by 2, which implies d theta is equal to 2 times du. When theta is equal to 0, since we are doing substitution, we have to take care of the limits. So when theta is equal to 0, u is 0. And when theta is equal to 2 pi, u is equal to pi. S is equal to 2a times the integral from 0 to pi of sine u times 2 times du, which is equal to 2 is a constant. We take it out, we get 4a times the integral 0 to pi of sine u du. And sine u integral is minus cos. So we have s is equal to 4a times minus cos u from 0 to pi. S is equal to 4a times minus cos pi minus minus cos 0. So we get s is equal to 4a times 1, because cos pi is minus 1. Minus times minus is plus 1. And here minus minus plus cos 0 is 1. 1 plus 1 is 2, 4 2 is 8. So we have S is equal to 8A. So again, here as well, if you notice that we just have to know the A, value of A, to figure out the arc length between 0 to 2 pi. That was rectification of a curve when the curve is given to us in the polar form and the parametric. Now, if you found this useful, don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now.